Hello again. Really quick lesson on right triangle trig where I'm actually going to use an application of the inverse. Now I didn't go over the inverse yet, and I'm going to explain that as we go along. And that'll be fine. That's going to be perfect, but I don't think the grasp of the inverse is something that people understand just yet. But I want to do a basic problem because you'll see this immediately and people don't know what's going on, which is fine. And you keep going with it and then all of a sudden it makes sense. Basically what I want to do is I want to find A and I want to find B. And A and B stand for degree measures in a triangle. So we're going to go ahead and we're going to try to figure out what this is equal to and what this is equal to. Now I know this is a right triangle, so we can use sine, cosine, or tangent. And we're going to have to kind of apply our skills of sine, cosine, and tangent in order to figure it out. Now, you can also use secant, cosecant, and cotangent, but I wouldn't recommend that you do that. What I would recommend is that you pick which one you want to solve. You want to solve either A or B. A goes first, so let's solve A. Now the question is, do you want to use the sine of A, the cosine of A, or the tangent of A? And people say, well, I just want to use whatever's easiest. And that's fair enough. That's perfect. Now, which one of these three values do you not think is easiest? And people say, this one. I don't want to use this one. I hate this one. Okay. Don't have to use it then. So what we're going to do then is we're going to try to figure out A, which means this is our opposite, this is our hypotenuse, and this is our adjacent. Now, we want to figure out the sine, cosine, or tangent of A, but we don't want to use the adjacent side. So, what uses opposite and hypotenuse? Well, cosine uses adjacent over hypotenuse, and I don't want to use this one, so let's not use that one. Tangent uses opposite over adjacent, I don't want to use that one. Sine uses opposite over hypotenuse. So, go ahead and erase this. The sine of A is equal to the opposite over the hypotenuse. Well, the opposite is 3. The hypotenuse is 6. Now, notice when I told you to write this, don't just write 3 over 6. You have to write sine of A equals 3 over 6. So sine of A equals 1/2. We're trying to figure out the A. This time we're actually trying to figure out the degree. We're not trying to figure out a fraction or a ratio, but we're actually trying to figure out this degree. Now, I made this problem easy for me to do in my head. I mean, that's really all there is to it. Could have picked something that was more difficult, but I didn't. Now, what I want to do is I want to get A by itself. I can't divide sine of A. That doesn't work. I can't multiply it. I can't add it or subtract it. What I have to do is do something called its inverse function. And its inverse function is basically the sine, except it's got a -1 on it. It's got inverse sine. It's not the reciprocal of sine, it's called the inverse function of sine. But what I do on one side of the problem, I better do on the other side of the problem. So, inverse sine and the sine become null and void. Well, not null and void, but and all I'm left with is A. A equals, and what you would do is you would put in second sine, parentheses, 1 divided by 2, close parentheses. That's how you plug it in. I'll show you. Inverse sine of 1/2, close parentheses. And what you get is A equals inverse sine of 1/2 comes out to 30 degrees. So my A is 30 degrees. Like I said, it actually worked out very, very nicely for me. A equals 30 degrees. I want to figure out my B. Well, this is a 90-degree triangle, a right triangle. If this is 30 and this is 90, what's this measure going to be in order to complete that? 60. Very easy problem. Now, they don't always come out nicely, like 1/2, and it doesn't come out to 30. It usually comes out to like, I don't know, 34.87, whatever. Just round to the nearest tenth of a degree and go ahead and then figure out its complement. But that's something that I could do off the top of my head because I don't got a calculator with me. So that said, that's a very simple application of inverse. Hopefully that was helpful. Have a good day for right now. Goodbye.